Hello everyone and welcome to my channel. In this video I'm gonna discuss the QUALITYWINGS BAE AVRO APU. As you may know that the APU is used to produce bleed air and electrical power. It's a vital component or element among the aircraft system. The APU can be used for the air conditioning on the ground when no engine is running, or it can be used as an alternative source for air when the engine's bleed air are totally reserved for takeoff and go-around performance. The APU can also supply AC power to the full electrical system and engine start. I will discuss in more details the APU operations later on in this video. Now I'm gonna give you a quick description on the APU system, and then later on I will do some tutorials on how to operate the APU. The APU unit is located in the tail cone section and has an intake opening on the left side of the aircraft tail and an exhaust opening in opposite side. The APU control and indications are located on the overhead panel. The fire protection system is not modeled by QUALITYWINGS software designer, therefore I will skip this from the APU description. The APU start-stop switch is used to start and stop the APU. The APU operation is monitored by the pilot through the RPM and exhaust gauges. During normal APU operation, the RPM and AGT will remain within the green band. The APU uses the fuel from the left inner feed tank. During the APU start, the fuel is drawn from the left inner feed tank by suction feeding. To start the APU, a DC power source must be available. This DC power can be from the battery or TR1 or from an external DC power. One of these DC power sources will power the APU start through a DC start bus. When using the battery for the APU start, a 24 volts minimum is required from the battery. When the APU is running at its normal constant speed, which can be confirmed by APU power available annunciator green light, it can supply AC power through an APU generator, which is controlled by the APU generator switch. When the aircraft is on the ground, the APU generator is capable of supplying power to both AC bus 1 and AC bus 2. In flight, the APU can supply one AC bus only, and the AC bus 1 has priority over the AC bus 2. The APU bleed air has an on-off control switch located in the air supply panel. When on position is selected, this will allow the APU air to flow to both pack 1 and pack 2. Then the air conditioning can be used by turning the packs to on. The bleed air and air conditioning system will be covered in other video. Let's now do some tutorials step by step on how to operate and use the APU. I'll walk you through a different situation starting from cold and dark panel state. Let's see first how to start the APU using the battery. This is usually a situation where no external power is available to power the aircraft on the ground. Now I turn the battery on, DC meter set to battery, the battery voltage checked for a 24 volts minimum. Before we start the APU air switch must be checked off, then the APU valve not shut annunciator should be checked dark. The APU generator switch can be selected on before APU start. The advantage of doing this that the APU generator will automatically supply the power to the system after a complete APU start cycle. Now from the APU control panel, we initiate the start by selecting the start-stop switch to start. Start power on, annunciator lights up, confirming that the DC start bus is being energized. APU fuel valve annunciator illuminate briefly as the fuel valve is moving to open position. APU fuel low pressure annunciator on, indicating that the fuel being drawn from the APU is sensed by the APU fuel pressure. Smooth increase in EGT, normal acceleration on RPM. At 50% RPM, start power on annunciator goes out to confirm that the DC start bus is no longer powered. APU power available annunciator comes on shortly after 95% RPM is reached. The system now is being powered from the APU generator, and this is confirmed by the annunciator's amber lights out and APU load meter showing a load. So far the APU is using the fuel by suction feeding, causing the APU fuel low pressure to remain on. Now we can boost more fuel to the APU by switching the left inner fuel pump on. And finally, the APU fuel low pressure is out. The other scenario of starting the APU will be with an external power source. This is the situation where the aircraft is on the ground for an extended time prior to flight. As you can see, the aircraft electrical system currently is powered from an external AC source. The APU may be started directly from an external DC power, but this option is not simulated by QUALITYWINGS software designer. In this case, we can use only an external AC power. And here is the point. Whenever the AC bus 1 is energized, whether from the external AC power or from engines generators, the APU can be started using DC power from TR1. Then the APU start sequences will be the same as I showed you earlier, except this time you can turn the left inner fuel pump on prior to the APU start, since the AC power is already available from the external AC power. The only difference here is that the system is already powered from the external AC power, and selecting the APU generator on earlier will automatically take over the electrical system supply from the external AC power. This means that the APU power has priority over the external power. As you can see here, after a complete APU start, the APU is automatically connected to the electrical system, which is confirmed by the APU load meter showing a load. Now you can use the APU air for air conditioning by switching the APU air to on, and the packs are turned on. And you can disconnect the external power from the aircraft using the QUALITYWINGS control panel. This is typically the way we use the APU during the ground operations prior to flight. Now, if the APU generator will be used for the engine's start, just prior initiating the engine's start, we must turn off the APU air. And here is the procedure. First we turn off the packs, and then APU air switched off. Now we can start the engines. I won't cover the complete engines start in this video, since this is not the topic of this video, so I'll jump to after a complete engines start. Now all engines are running and ready for departure. As soon as the engines are stabilized at idle, we can configure the air supply panel for departure. The APU can be used for the takeoff and go round air configuration to satisfy the engine's performance by leaving all engines air switches off, APU air switched on, packs on, and this is the way the APU air is used to increase the engine's performance for takeoff and go round. To stop the APU, we simply switch the start-stop switch to stop. And this completes the QUALITYWINGS BAE AVRO APU overview. Thank you for watching and see you in the next video.